Hey everyone, so I clicked on this video because you want to learn how to solve a system of equations that has a linear equation and a quadratic equation. In this video, I'm going to show you some easy steps on how to do that. Systems of equations, in some countries, it's also known as simultaneous equations. In this video, I'm going to be showing the same concept even though it's known by two different names. Now, if this concept is too advanced for you, maybe click on this link up here to learn how to solve a quadratic equation using the factoring method. If you already know how to use the factoring method, then click on this link up here to learn how to use the quadratic formula. My name is Peter, grab your calculator and let's get started. So today's objective is to solve a system of equations involving a linear equation and a quadratic equation. Whenever you want to solve, you have the option of whichever method you want to use. So you can use the quadratic formula as shown here on the screen, or you can use the factoring method. Now let's try to understand what does it mean to solve a system of equations. Whenever you're solving a system of equations, you're actually looking for how many times the two equations cross each other. So in the first scenario here, you have the quadratic equation, which is this blue line, and you have the linear equation, which is this red line, crossing each other at 2 points. So this type of a system is going to have two solutions. In the second scenario, you have the quadratic equation, which is the blue line, the linear equation, which is the red line. They cross each other at only one specific point. And that means this type of a system has one solution. In the final scenario, you have the blue line and the red line not crossing each other at all. In this situation, they have zero real solutions or they have complex solutions. In this video, I'm not going to present an example that has complex solutions. That's going to be in a separate video. So now let's start with the first example. So the first example we're going to look at is y equals to x squared minus 2x minus 3 and y equals to 2x minus 3. So we want to find out where does the quadratic line and the straight line, the linear line, where do they cross each other? So since both of them are set equal to y, we're going to set both equations equal to each other and then solve. So the first thing is to write x squared minus 2x minus 3 on the left side and 2x minus 3 on the right side. And then I need to move everything that's on the right side over to the left side so that I can be able to solve this equation. So if I move a positive 2x over to the left side, it's going to become negative. So x squared minus 4x. Because negative 2x minus 2x is negative 4x. This negative 3 here, if I move it over to the left side, it's going to become positive. So positive 3 plus negative 3 is 0. So this is going to be equal to just 0. This equation here, you can solve it using the quadratic formula, but that's not necessary. There's a quicker way. All we need to do is just to remove the common factor, which is x. So x parentheses x minus 4 equals to 0. So now I can set each factor equal to 0. So I'm going to write x equals to 0 or x minus 4 equal to 0. So I already know that one of the solutions for this system up here is when x equals to 0. Now I need to solve this other side. So to solve it, I'm going to move that negative 4 to the right side and I'm going to get x equals to positive 4. So this is the second solution. Now these two values here are the x values. Now we need to find the y values. So to get the y values, I'm going to use this linear equation because it's simpler to work with. And I'm going to substitute x with 0 and it's going to be y equals to 2 times 0. 0 comes from the first solution that I got here, minus 3. 2 times 0 is 0, 0 minus 3 is negative 3. And then I'm going to repeat this process, but I'm going to use x equals to 4 to find the second point. So 2 times 4 minus 3 equals to positive 5. These two equations, they cross each other at 0, negative 3 and 4, positive 5. And those are the solutions for this system. In the second example we're going to look at, we have y equals to x squared minus 4x plus 4, and the second equation, which is linear, is y equals to x minus 2. As always, the objective is to set the two equations equal to each other so that we find out where do they cross, if they cross at all. So let's go ahead and do that. On the left side, we have x squared minus 4x plus 4, and on the right side, we have x minus 2. So we need to move this x over to the right side, and over to the left side, and it's going to be x squared minus 5x, because this positive x, when it goes to the other side, it becomes negative. Now we need to do the same thing with the negative 2. Because it's negative 2, when you move it over to the other side, it becomes positive. So positive 2 plus 4, it's going to be positive 6 equals to 0. Once you get to this point here, you can use any method to solve this quadratic equation. I'm going to use the quadratic formula. So I'm going to choose my a, which is 1, b is negative 5, and c is 6. X equals to negative 5 plus or minus square root of negative 5 squared minus 4 times 1 times positive 6, close parentheses, divide by 2 times 1. And then, so the next step here is we're going to simplify. So the two negative signs here are going to combine to make a positive 5. And then inside the parentheses, negative 5 squared is 25. Negative 4 times 1 times 6 is negative 24. So 25 minus 24 gives you square root of 1. And in the denominator, it's a positive 2. So this means that we're going to have 5 plus or minus 1 divided by 2. Because it's plus or minus, we know that we're going to have two solutions for x. So the first solution is 5 plus 1 divided by 2, or x equals to 5 minus 1 divided by 2. So we're going to solve the left side first. 5 plus 1 is 6 over 2. When you divide those two numbers, you get 3. And then on the right side, 5 minus 1 is 4 divided by 2. 4 divided by 2 is positive 2. So 3 and 2 are the x solutions. So now we need to find the y solutions. So I'm going to take 3 and I'm going to use the linear equation to find y. You can use the quadratic equation, but it's a little bit easier if you use the linear equation. So y is equal to, I substitute x here with the value of 3. So it's going to be 3 minus 2 equals to 1. And then I take the same linear equation, substitute x with the value 2. So 2 minus 2 equals to 0. So the 2 points are 3, 1 and 2, 0. These are the 2 points where these two lines cross each other, and those are the solutions. So here's the final example we're going to look at. We've got our quadratic equation y equals to x squared minus 5x plus 3 and our linear equation y equals to x minus 6. Both of the equations are set equal to y, so that means we can set both of them equal to each other. So we're going to start off with x squared minus 5x plus 3 is equal to x minus 6. And then now we need to move the x over to the left side, and we also need to move the 6 over to the left side. When you move that positive x over to the left side, it becomes a negative x plus the negative 5x gives you negative 6x. When you move the negative 6 over to the left side, it changes from negative to positive 6. And then you get plus 9 equals to 0. So this quadratic equation is the one that we want to solve. So when you solve it, we're going to use the quadratic formula, or you can use any other method. And so with the quadratic formula, it's going to be x equals to negative 6 plus or minus square root negative 6 squared minus 4 times 1 times 9 divided by 2 times 1. So now we're going to simplify, and I'm going to start off with the two negative signs here and change that to positive 6 plus or minus, and then inside the square root, negative 6 squared is 36, 4 times 1 times 9 is 36, so 36 minus 36, you get square root of 0 divided by 2. Square root of 0 is just 0, so 6 plus or minus 0 divided by 2. And then so the final step is now to solve. Here, even though it's plus or minus, we're not really going to solve two equations. We're just going to solve one, because whether you add 0 or subtract 0, it doesn't really change the calculation. So it's going to be x equals to 6 divided by 2, which gives us 3. So this is the x value of this system. So what we're going to do, we're going to take the 3, plug it into the linear equation, and you're going to get y equals to 3 minus 6 equals to negative 3. So that means the point where these two lines cross each other is positive 3, negative 3. These two equations only cross each other once, and that is at this point here, and that's the solution. Here's the pro tip. If you're solving a system of equations, make sure you set both equations equal to each other. Once those two equations are set equal to each other, then you need to rewrite the equation where you have all the terms on one side and 0 is on the other side. Identify which are your coefficients A, B, and C, solve that quadratic equation, and then you'll find the solutions of that system. And that's the pro tip. After working on several examples, here are some independent exercises for you to try on your own. Solve the following systems of equations using any method. You can use the factoring method, or you can use the quadratic formula to solve these systems. All of the answers for both exercises can be found in the description below. Good luck!